This video is about one of the methods for solving a system of equations. Remember, a system of equations means we have more than one equation, and the solution means that it's where we find an x and y that work in both. And so we can definitely graph them, but that's not always completely accurate. And so, or easy to find the answer rather, especially if it's a fraction or a decimal. And so we have other methods that can do that and give us an exact answer. And one of those is the substitution method. So let's take a look at some examples. So for the system, we're going to use the second equation to make a substitution for x. In the first equation. So again, substitute, just like a teacher, substitute teacher, someone's filling in that spot for a short time. And so we're going to look at a system of equations. So that is going to be x plus 5y minus 10 equals 0. And then x equals 2y minus 8. So here's our system of equations. And so substitution means we're going to plug stuff in. So this says use the second equation to make a substitution for x in the first equation. So where x is in the first equation, we're going to plug in everything that x is a value of. So an equal sign means they are the same. So in the second equation, we're saying x is the same as 2y minus 8. So when we make a substitution, instead of saying x, we're going to say 2y minus 8. So what is that resulting equation going to look like? Well, let's take a look. So we're going to rewrite the top one. Instead of saying x, we're going to say our new piece, 2y minus 8. So 2y minus 8 plus 5y minus 10 equals 0. So we've made the substitution. Now we just want to make it look pretty and kind of clean it up. So like terms. So these are alike and those are alike. 2y plus 5y is 7y. And negative 8 minus 10 is going to be negative 18. And so that would be our resulting equation when we substitute that in. Next example. We're going to solve the system by using the substitution method. So here is our system that we're going to work with. 8x equals 2y plus 5, and 3x equals y plus 7. So when we use the substitution method, it doesn't matter which letter, and it doesn't matter which equation. So it's kind of up to us to choose. So we could either substitute the x, we could substitute the y, and we can substitute the second into the first or the first into the second. Really doesn't matter. I'm going to look at this bottom one. So sometimes after doing a bunch of these, you start to see like hints where it make it a little easier. Because I have one of the variables, in this case y by itself, there's no coefficient in the front, I'm going to solve for y. So in this case it would be y equals negative 3x plus 7. Because it makes it easier to not have any fractions if I have a variable that only has a coefficient of 1. So what we just did there is solve for y, which means y is the same as all of this. So y is the same as negative 3x plus 7. Now because I know that difference, that means that anytime I see y in the first one, that's where I'm going to plug it in. So let's rewrite the first equation. 8x equals 2y. Oh, but we know what y is. So instead of y, we're going to write in negative 3x plus 7 plus 5. So everything else is still there from that equation. We just changed the y. All right, so now we just want to simplify it. So we're going to have to distribute the 2. So we have 8x equals 2 times negative 3 is negative 6x. 2 times 7 is 14 plus 5. And then next we are going to keep solving. So if we look at this, now we can actually solve this equation because we only have one variable. Before we had 2, there's no real way to solve that. So here we can continue to solve. So these two are alike, but I can also add 6x to both sides to get the x's on one side and numbers on the other. So 8 plus 6 is 14x. That's 0. 14 plus 5 is 19. All right, and then we just need to divide both sides by 14. And we do get a fraction, but that's fine. It can happen. 19/14. So this is something that we wouldn't necessarily see on the graph. We would see that they cross, but we couldn't quite tell where they cross. But we're not done because remember the solution means that it is the one x and the one y that they cross at. We have found the x, but we need to find the y. So now we can take that x and plug it into this equation here and get the y value. So y equals negative 3 times 19/14 plus 7. All right, so in order to multiply negative 3 times 19/14, remember that we can write negative 3 as a fraction by putting it over 1 and then multiplying straight across. So we have negative 3 over 1 times 19 over 14 and multiply straight across. So we have negative 3 times 19 gives us negative 57, and 1 times 14 is 14. We can check and see if that actually divides or simplifies, and it looks like that's as good as it gets, but we're not done. So we have y equals negative 57/14 plus 7. So the next thing we need to do is to add those numbers. So we have negative 57/14 plus 7. So we need a common denominator. Make them both 14. And so this one is already there, so that one's going to stay negative 57. But to get from here to here means we multiplied by 14. So 7 times 14 gives us 98. And now we can add them together. So we keep the denominator, but we add the numerators. So we have negative 57 plus 98 gives us positive 41/14, and we see if we can reduce that at all. And it looks like, well, 41's a prime number. So what is our actual solution to this system? And that is a point. So it's at the point 19/14, because that was our x, and 41/14. All right, let's look at another example. Last example, we're going to solve the system by the comparison method. So this is just kind of a different take on the substitution method, comparison method. So let's get our two equations up here. 2p plus q equals 1. 9p plus 3q plus 3 equals 0. So what does it mean for the comparison method? Well, let's solve each of these for q. So we want it to be q equals. So the first one we're going to have to subtract 2p from both sides. So we get q equals 1 minus 2p. And the next one is going to take a couple more pieces. So we're going to have to subtract the 9p. We're going to have to subtract 3 from both sides. So we have 3q equals negative 9p minus 3. Then we have to divide everything by 3. So we get q equals negative 9 divided by 3 is negative 3p. Negative 3 divided by 3 is a negative 1. Okay, so what is our comparison method? Well, now we have q equals 1 minus 2p and q equals negative 3p minus 1. So it is a substitution in a way because now we have q equals. So what we do is we kind of eliminate that and realize, okay, well, if q equals, then we're going to set this piece equal to this piece. So we have negative 3p minus 1 equals 1 minus 2p. All right, so I'm going to give us some more room so we can continue to solve this because we are not done. That's just the process. Okay, so let me rewrite that. Negative 3p minus 1 equals 1 minus 2p. Okay, so now we want to continue and solve for p to see what we get. So our next step is to get p's on one side and numbers on the other. So I'm going to add 3p to both sides. So we have negative 1 equals 1. Negative 2p plus 3p is positive 1p. And then we're going to subtract 1 from both sides. And we get p equals negative 2. But now we have to take that and plug that back into either one of the originals that we were given or one that we solved for. So one of the originals was 2p plus q equals 1. And again, it doesn't matter which one you plug it in. So we're going to plug that in for p. So we have 2 times negative 2 plus q equals 1. So negative 2 times 2 is a negative 4. And to get q by itself, we need to add 4 to both sides. So q equals 5. So what is our solution? Negative 2, 5. So if we were to graph those two lines on the same Cartesian coordinate plane, we would see that that is where they cross. They cross at negative 2, 5. That's it for this video. As you work through the lesson, if you have any questions, be sure to ask your teacher. Have a great day.